The Big Bang Theory predicts that all matter, time, and space began at an incredibly tiny compact state about 13.8 billion years ago. This initial state was a hot, dense, uniform soup of particles that filled space uniformly and was expanding rapidly. The scientists' observations of the movements of galaxies tell us that the universe is expanding at an accelerated rate. We have three main possible scenarios for how our universe is expected to end: the Big Freeze, the Big Crunch, and the Big Rip. The answer mainly depends on whether the force of gravity will win over the repulsive force expanding the universe, also known as dark energy, or the other way around. We are not sure yet which scenario will happen. The Big Freeze is expected to occur if the repulsive force wins over gravity. In that case, the expansion of the universe will not continue accelerating. Still, the universe will keep getting bigger, galaxies will separate, and stars and planets will move away from each other. The light they emit is expected to be redshifted to long wavelengths with very low energies. The universe is expected to become darker and colder, approaching a frozen state known as the heat death of the universe. The Big Crunch is expected to happen if the force of gravity wins over the repulsive force. In that case, reversing the universe's expansion, galaxies are expected to start rushing toward each other, leading to a stronger gravitational pull. Space would get tighter, and temperatures are expected to rise, leading to an extremely dense, hot, and compact universe, comparable to the state that preceded the Big Bang. One of the proposals introduced in the book The Big Defreeze of the Universe by Muhammad Hassan Al-Ghari is that our universe is expected to end the same way it started. We are not sure whether it will be the Big Freeze, the Big Rip, or the Big Crunch. The Big Defreeze is the idea proposed in this book as the scenario that happened at the beginning of the universe preceding cosmic inflation. The idea of the Big Defreeze is compatible, at least partially, with any of these scenarios, which is explained in further detail in the book. The Big Defreeze could potentially explain what preceded inflation and the Big Bang. It could also potentially explain the reason behind the actual bang of the Big Bang. Additionally, the book goes a step before the proposed Big Defreeze to use an analogy called the straight line analogy, which could also explain the driver of the Big Defreeze mechanism. The straight line analogy considers that our universe, or even multiverse, has a one-dimensional representation of reality in the form of a straight line. This analogy is based on the holographic principle, cosmic inflation, the landscape of string theory, topological manifolds, and manifold bundles. Suppose you consider the two-dimensional data and the three-dimensional data as two versions of reality, or two reconstructions of the same reality. Then why do we not have a third version or a third reconstruction of reality in one dimension represented in a straight line? The analogy goes that we have a straight line as a one-dimensional representation of reality, and a tiny fluctuation happened on that straight line. This fluctuation was then projected on another space, forming the identity stem wave of the universe ISWA-U. Fluctuations and interactions started happening to form an identity stem wave ISW crystal. The book proposes that when all matter, even if it is not bosons or ideal gases, are shattered to their elementary particles, form Bose-Einstein condensates. These matter waves started fluctuating, forming what is referred to as the identity stem waves, until the winding frequency of helium's ISW caused the symmetry breaking of the ISW crystal, leading to the Big Bang and inflation. The book also addresses the fermions problem. The book suggests as well that the Big Defreeze would require three complex forces: the R force, the retrieving force; the B force, the balancing force; the HD force, the higher dimension force. The book explains the definitions of these three forces, their properties, their potential operations, and how they could potentially work with physics' current known fundamental forces. The book then proposes the two worlds interpretation. It briefly presents the many worlds interpretation and the measurement problem. Then it explains the idea of the two worlds interpretation, which is simply that we have two worlds, one in our universe on a two-dimensional holographic film, having quantum mechanical behaviors, and the other one is totally outside our universe or even the multiverse and its space-time parameters, which do not follow the quantum mechanical behavior. The version of you in our universe is an observer with constituents following the quantum mechanical behavior, which requires the second version of you in the other world with constituents that do not have quantum mechanical behavior. More details and some proposed equations are in the book The Big Defreeze of the Universe.